We need to talk today about simplifying radical expressions. So if I think about this first one here, the square root of 64, okay, we recognize we are taking the square root. That means a number multiplied by itself to give you 64. Well, we know that 64 is a perfect square. It's a perfect square because I know that the square root of 64 is 8, and 8 squared is 64. So pretty simple for that. Now let's do something different. Let's take the square root of 63. So recognize again, I'm taking the square root. Now 63 is not a perfect square, but I can factor 63 as 9 times 7, and I know that 9 is a perfect square. So to simplify this in what we call simplest radical form, this is the square root of 9 times 7. And you recognize that 9 is a perfect square. So this is 3 root 7. So that is simplified. That's the exact answer of simplifying the square root of 63. Now, if I wanted a decimal approximation, I could use my calculator. But this is what we call simplest radical form. And what it means for square roots is you have taken the square root of any perfect square. So if I look at the square root of 20, so you can break it down. You know that 20 is divisible by 2 and 10. That's divisible by 2 and 5. So this is a perfect square. That's the number 4. And so 4, so it's 2 squared, which is 4. So this is the square root of 4 times 5. The square root of 4 is 2. So your answer is 2 root 5. The square root of 150. So again, if I look at 150, I know that that is 2 times 75. And if I divide by 3, that's 3 times 25. I can stop here because that's a perfect square. Okay, so I know that this is going to be the square root of 6 times 25. The square root of 25 is 5. So this final answer is 5 root 6. The square root of x squared. So the square root, what number can I multiply by itself and get x squared? Well, that's just simply going to be x. The other way of thinking about this is the square root undoes the squaring. They're inverse operations. Or I can write this in exponential form. This is x squared raised to the 1/2 power. That's what it means to take a square root. In this case, I multiply the exponents. So this is x to the 1. If I look at the next one, the square root of x cubed, well, this is the square root of x squared times x. Well, the perfect square is right here. The square root of x squared is just x. So that comes outside of the radical. So this final answer is just x square root of x. So again, simplest radical form. Now if I look at the next one, I'm taking the cube root. So the cube root means I need to organize things under the radical in perfect cubes. The cube root means a number that you can raise to the 3rd power and get what's there. So what number can I raise to the 3rd power and get x cubed? That's just x. The cube root of x cubed is just x. Or the other way of thinking about it, this is x cubed to the 1/3 power. You multiply exponents and you get x to the 1. The cube root of x to the 5th. Well, since it's a cube root, let's organize the perfect cubes. I can rewrite x to the 5th as x cubed, x squared. Now my perfect cube is right here. The cube root of x cubed is just x, and I'm left with the cube root of x squared. Now, it's slightly different. In the previous problems, when I was taking square roots, I organized perfect squares. Cube roots, I'm organizing perfect cubes. Okay. Let's look at this one, the square root of 50, x to the 4th, y cubed, z to the 5th. So I got to work on the numbers and the variables. So 50 is just what, 2 times 25? So there's my perfect square right there. So this is the square root of 2 times 25. Since it's a square root, I can rewrite x to the 4th as x squared. I can rewrite y cubed as y squared y. And z to the 5th is z squared, z. Now the reason I wrote all of this out, because now I want to see the perfect squares. I'm going to highlight all of the perfect squares, because those are things that are going to simplify and come outside of the radical. So the square root of 25 is 5. The square root of x squared is x, and I see that happening twice. The square root of y squared is y. The square root of z squared is z, and I see that happening twice. And then what's left under my radical is what? 2y z. So again, you just want to be very organized about organizing things in perfect squares in order to simplify a square root. Let's look at when we're multiplying expressions with radicals. I can combine these radicals. So this is the square root of 16x squared. Those are both perfect squares. The square root of 16 is 4. The square root of x squared is x. Negative square root of 50 over x to the 5th over 2x. I can combine all of this into one radical. 50 x to the 5th over 2x. So this is negative square root, sorry, I wrote that wrong, x to the 5th. So this is what, 25 x to the 4th, or negative square root 25 x squared. Those are all perfect squares. The square root of 25 is 5. The square root of x squared is x, and I've got 2 of those. So this is negative 5 x squared. Here, if I multiply, so the things that are outside the radical, 2 times 3 is 6. And then under that radical, you've got what? So if I think about this, when I multiply 5 times 15, I get 75, which is not a perfect square. So I can think of this as 5 times 15, which is what? 5 times 3. And then x to the 4th. So what I see here is that's going to be a perfect square. So I can write this as 6, the square root of 5 squared times 3, x squared. So the perfect squares are right here and right here. So the 5 comes out, 6 times 5 is 30. The x squared, the square root of x squared is x, and I have 2 of those. And the only thing that's left under that radical is the square root of 3. Looking at this one, so I've got 2. So 12 times 18 is not going to be a perfect square, but I can look at what 12 is what 2 times 6, which is 2 times 3, and then 18, which is 2 times 9, which is 3 times 3. So I can see my perfect squares here. That's a perfect square right there, and this is a perfect square. So this is going to be the square root of, what have we got? 2 squared times 3 times 2 times 3 squared. That's all the numbers, and then x to the 14th. So what you can see here is the 2 is going to come out. So you'll have 2 times 3, and you're left under the radical of x to the 14th, I can write that as x squared 7 times, right? Or if you think about it, if you're trying to take the square root of x to the 14th, that's x to the 14th raised to the 1/2 power, which is x to the 7th. So this final answer is, 12 x to the 7th and the square root of 3. Cube root of 225 over 75. This is the cube root of 225 over 75. So I've got to see, are there any perfect squares or perfect cubes in here, okay, for this particular one. If I simplify this, when I divide by 5, so 5 will go into there, 45, so it's cube root of 45 over 15, okay, which is just the cube root of 3. And no further simplifying because 3 is not a perfect cube. The fourth root of all of this, okay, so this is 2 to the 5th, and that's 2 to the 3rd, so you're going to have the fourth root of 2 to the 5th and 2 to the 3rd, and then x to the 5th y cubed. Because this is the fourth root, I want to organize everything in perfect fourths. So this 2 to the 5th, 2 to the 3rd, that's 2 to the 8th. So I can rewrite that as 2 to the 4th, 2 to the 4th, and then x to the 4th, x, y cubed. Now I look for my perfect fourths right there and right there. The fourth root of 2 to the 4th is 2, and I've got 2 of those, so 2 times 2 is 4. So this is 4x, and then what's left under that radical is xy cubed. Now when we add and subtract, keep in mind, we always only add and subtract like terms. So this is saying you've got 1 square root of 3, and you add it to 1 square root of 3, and you end up with 2 square root of 3. Basically, you treat the square root of 3, you're doing the same thing you would do if this was x plus x. Now, if I look at the next one, these are unlike terms, but I've already demonstrated that 20, what is that, 4 times 5? So the square root of 20, that's the square root of 4 times 5, which is 2 root 5. So this is 5 root 5 minus 2 root 5. Now they are like terms. Final answer is 3 root 5. Okay, so initially I can't add those together, but there I can. The square root of 3 plus the square root of 5. Well, 3 is prime, 5 is prime. I cannot add these together and simplify. I mean, I can get an approximation with my calculator, but there's nothing else I can do to simplify this. Look at this one, the square root of 18. Remember 18 is what, 2 times 9? So the square root of 2 times 9 is going to be 3 root 2. So I'm going to have 3 times 3 root 2 plus 2 root 5 minus 2 root 2. So this is 9 root 2 plus 2 root 5 minus 2 root 2. The like terms are the square root of 2's. So final answer here is 7 square root of 2 plus 2 square root of 5. Simplify and evaluate, okay? So 3 root 2 plus 3 root 2 is what? That's 6 root 2. So this is 6 root 2 minus 1 root 2, which is just 5 root 2. Next one, these are all like terms. So 2 minus 3 minus 2. The 2's cancel. This final answer is just negative 3 root 6. Next one, I just have to see, do they simplify? So if I look at square roots, look at 8. 8 is what, 2 times 4? There's my perfect square. So the square root of 4 times 2 is 2 root 2. So that's what 8 is. And then 18, that's 2 times 9. So the square root of 2 times 9 is 3 root 2. So this problem is 2 times 2 root 2 plus 3 root 2 minus 2, 3 root 2. So this is 4 root 2 plus 3 root 2 minus 6 root 2. So that's 7 minus 6. Final answer here is just the square root of 2. So the key to simplifying, so if I look at this one, my key is going to be, can I simplify perfect cubes? So I don't want perfect squares here because it's the cube root. So if I look at 48, if I divide that by 2, or let's just do it, this is 2 times 24, which is 2 times 12, which is 2 times 6, which is 2 times 3. So the perfect cubed is right there, those 3 2's. So this is what, 8 times 6. And that's my perfect cubed right there. If I look at 162, that is 2 times 81, which is, that's 3 times 27, which is 3 times 9, which is 3 times 3. My perfect cube here is right there. Okay, so this is what, 27 times 6. That's how I get my perfect cubes. Okay, so if I rewrite this problem, this is 3 cube root of 8 times 6 minus 2 cube root of 27 times 6. My perfect cubes, or by design, I've organized them this way. So the cube root of 8 is just 2. So when that 2 comes out, you're going to get 6 cube root of 6 minus cube root of 27 is just 3. So I'm going to get 6 cube root of 6. This answer is 0. And that should lead us up into the homework for this section.